physical and chemical change, and we put the students into 3 groups, and we gave them the materials of Alka-Seltzer packets, warm water, room temperature water, and Dixie cups. And our complex question for the class was, what characteristics of a material affect a physical or chemical change?
All 3 groups initially did temperature for their question, but then the 3rd group was directed in a different way, so they weren't all temperature.
Okay, group 1 and 2 did similar experiments. Group 1's question was, how does the temperature affect the speed of a chemical change? And their claim was that hot water will have a faster change than the colder water.
And group 2's question was, does the temperature of the water affect the rate of the chemical change? And their claim was, the hotter the water, the faster the chemical reaction.
So group 1's evidence, they took 2 cups, one of hot water, one of cold, and they timed at the speed of which the Alka-Seltzer dissolved, and there was a 30-second gap in between them. And
for group 2, they also had 2 cups, and they put hot water in one and the room temperature in the other, and they put the Alka-Seltzer in at the same time, and they said that the cup with the hot water had higher column of bubbles than the other and also fizzled out first, which indicated a quicker reaction for the hot water.
So our claim was similar to both groups because our question was, how does temperature affect the rate of a chemical change? And our claim was, as temperature increases, the rate of a chemical change increases. So basically for all 3 of ours, the conclusion was that the hot water particles move faster, causing a faster chemical reaction. Okay, group 3, their question was, does the amount of the Alka-Seltzer affect the rate at which it dissolves? And their claim was, if you double the amount of Alka-Seltzer, you double the amount of time. And their evidence for this experiment was they placed 3 different size tablets in 3 different cups of water. The full tablet dissolved at 46 seconds. The half-size tablet dissolved at 42, and the quarter-size dissolved at 37 seconds. And their evidence doesn't support their claim because there wasn't a significant amount of time to say that it would have doubled. I mean, obviously, the full tablet dissolved slower than the quarter size, but their claim or their evidence didn't support their claim.
And then our group was confused when we saw this because we had a similar question, but our claim and evidence was different. Our question was, amount of material affect the rate of a chemical change? And our old claim was, as the amount increases, the rate of the chemical change decreases. And in our experiment, we had 2 cups of water, and in one cup we had 2 Alka-Seltzer, and in the other we had 4. And so obviously the one with 4 Alka-Seltzer would take longer to dissolve, but we were focused more on the amount of Alka-Seltzer rather than the rate at which it dissolves. So the new claim we would do was, when the amount of Alka-Seltzer is doubled, the amount of time at which it takes to dissolve also doubles.
After observing group 3, we came up with a new claim, so this is the experiment that we're doing for our new claim.
And we'll have 2 cups of water at room temperature and the same size, and we're going to have 2 Alka-Seltzers in one and one in the other to see if it actually doubles when we dissolve it. Okay, go.
After observing group 3's experiment, we thought that their error was cutting the Alka-Seltzer in half wouldn't allow them to accurately measure the amount of time it doubled with the Alka-Seltzer. So we conducted an experiment of our own, and we had one Alka-Seltzer in one cup, and we had two Alka-Seltzers in the other.
The cup with one Alka-Seltzer in it took 30 seconds to dissolve, and initially we thought that the one with two Alka-Seltzers in it was going to take double the amount of time, which would have been 60 seconds, when in reality, each Alka-Seltzer takes around 30 seconds to dissolve. So just because we're adding another one to this cup doesn't mean that the rate of it is going to change. And from Group 3's experiment and from our old experiment, we had cups that weren't clear, so we couldn't really see. All we were focusing on was up top if the bubbles were to clear, and that's what we were basing our time off of, at which rate it would dissolve. And in conclusion, the amount doesn't change the rate at which it dissolves. Go.
The third experiment we did that no one discussed in class was how does the size affect the rate of a chemical change, and our claim was that as particle size decreases, the rate of the chemical reaction increases. So for our experiment, we had 3 cups of water at room temperature, and in one we had 1 crushed up full Alka-Seltzer, and in the second cup we had 1 full Alka-Seltzer, and the last one we had 1 Alka-Seltzer that was cut in half. So we only put the half piece in.
And we realized that was wrong because we were measuring both size and amount. We changed them both. And so we are changing our experiment, and in the new experiment we're going to do, we have 2 cups with room temperature water, and we're going to take 1 full Alka-Seltzer and put it in one, and then we crushed up an Alka-Seltzer, a full one, and we're going to put it in the other, so the amount stays the same, just the sizes are changing.
Okay, ready? 1, 2, 3.
Our results showed that the cup with the pieces of Alka-Seltzer dissolved about 15 seconds quicker than the full Alka-Seltzer, and that supported our claim that the smaller the particles, the quicker it would dissolve.
So in conclusion, we observed that the reason the particles dissolve faster was because there's more surface area in the one that had crushed up Alka-Seltzer, and that surface area allowed the water to attack the particles at a quicker rate than it did with the one with the full Alka-Seltzer, because those particles acted slower than the first ones.